Section 5.2 Logarithmic Function. In section 5.1 we discuss about exponential function, and this is how we define exponential function. Let's say you have y equal 2 to the power x. This is one of the exponential function with the base 2. uh, let's say the name of this function is f of x. The meaning of that is, let's say if you take 1 as x, then the value of the function for 1 is 2 to the power 1, which is actually 2. For 2, the value of the function is 2 to the power 2, which is 4. For 3, it would be 8, and keep going. So for one input for that particular function, the output is 2. For 2 input, the output is 4, and then for 3 input, the output is 8. This is an exponential function. Now, logarithmic function means going back process, the reverse process. The reverse process of this function is called logarithmic function. So reverse process of exponential function is logarithmic function. So inverse of this function is called logarithmic function, and this is how we denote that: LOG, log, that is the short form of logarithmic function, and whatever base we use here. So if we are talking about the general function b to the power x with the base b, then the inverse of that function is denoted by log base b. And remember, this is this log and b, they come together. That's just a notation to denote inverse of this function, and then whatever comes after that, that's the input. Okay, so log base b of x is called logarithmic function of base b, which is inverse of b to the power x function. So in this section we are going to see how to convert between log to exponential form and how to evaluate log expression, and we are going to talk about some basic properties of the log function and its graph, and we are going to find out the domain of the function. So first of all, so as we can see, log function is actually inverse of exponential function. So if x and b are positive real numbers such that b is not equal to 1, then log function is defined as log base bx is called the logarithmic function with the base b, where y equal log base bx is equivalent to b to the power y equal x. Meaning, so if you go back here in this particular example, so log base 2 of 8, log base 2 means going back process of 8 gives you 3. So another way of saying the very same thing is, if you look at here, 2 to the power 3 is equal to 8, right? 2 to the power 3 gives you 8. So they are equivalent expression. So we have this equivalency form. This is in the log form and this is in the exponential form. So if you have log form, you can always use the value of b, x, and y to go to the exponential form. If you have exponential form, you can always go to the log form. They are equivalent form. For example, let's say you have log form here. So remember, y equal log base bx is equivalent to b to the power y equal x, right? B to the power y equal x. So compare this one with this one. So y is 2, x is 16, and base is 4. And then find out, just find out the exponential form. So base 4 to the power 2 equals 16, and that is right. That is a true statement. 4 square equals 16. So this is exponential form of this log equation. By doing the same thing here, the base is 5, the power is -1 equals 0.2, because 5 to the power -1 can also be written as 1 over 5, and that is equal to 0.2, and that is true statement. So we can always go from log to exponential and then exponential to log after finding the base, exponent, and the value. So here, don't forget that if you have b to the power y equal x, which is equivalent to log base b x of y. So if you compare this one with this standard notation, then b is 2. So log base b is 2 of 16 equal 4. So another way of visualizing this thing is, if you are looking at exponential function 2 to the power x, right, for 4 it gives you 16, and by going back, which will be log base 2 of 16, that will be 4. Make sense? So we can always go from exponential to log and log to exponential. Here, by doing the same thing, uh, here, we can find out, we can go to the log expression. Log base, the base is 27, of 3 is 1/3. Okay, we want to find out the value of this log expression without using a calculator, if that is possible. So for that, what we can do is always assume that that log expression is y, and we want to find out the value of y. What is y? We want to find out that thing, and we can always do that by, you know, by going from log expression to, you know, exponential expression and solving for y. So if you go from here to exponential form, that will be 12 to the power y equal 144, and this is the exponential form. So to solve the exponential form, we can make the same base both sides. Here is a 12 and here is a 144, so I can write down that 144 as a 12 square. Because they have the same base, the exponent should be equal, so that means y should be equal to 2, meaning the value of y is 2. The meaning the value of log base 2 of 144 is 2. By doing the same thing, I can start saying that this is my y, and I can go from log form to exponential form by doing 64 to the power y equal 8, and 64 can be written as 8 square to make the same base, because there is a base 8 on the other side. And then now we have 8 to the power 2 times y equal 8 to the power 1. Power to the power is multiplication. So now, because the base is same, this is the property I'm using. If you have a to the power x equal a to the power y, if you have the same base, then x has to be equal to the y. So from here I can say 2y equal 1, and if I divide both sides by 2, it gives me the value of y, which is half. Y is nothing else, but y is this log base 64 of 8. That is our final finding. So some of the notation like log, some of the bases like 10 and then e, they we use them very often. That's why instead of saying log base 10 or log base e, we use this notation log for log base 10. That's called common logarithmic function. Because we work in decimal system, then that's the reason log base 10 is very 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 useful and frequently used notation. So instead of saying log base 10, we just say log. So 10 base is silent here, and there is another base e, which is an irrational number. Log base e is also a very popular log function with the base e. Instead of saying log base e, we just write ln, which stands for natural logarithmic function. So whenever you see ln, just think about log base e, and whenever you see log, think about log base 10. But these two notations are quite popular, that if you check your scientific calculator or most of the calculator, you will be able to find them on your calculator keypad. Okay, so what is the value of log 100? There are two ways to find it. One, you can use your calculator, or you can write it down like this: log base 10 of 10 square, which is actually 2. This one, log base ln e to the power -3, this is equal to -3. Okay, the reason for that is, I'm going to give you that reason. These are the basic properties of the log function. Log function and exponential function, they are inverse of each other. So whenever we try to find out composition of the inverse, they always give you whatever input you take, the same output you are going to get in from any order, from any direction. So since b to the power x and log base b, they are inverse of each other. That's why whenever they come together, for example here, this one, log base b of b to the power x, so you are taking the composition of function and its inverse. So that's why they have the same output. And here also composition of you know exponential and log function with the same base. So that's why you have the same x. Okay. And these two properties are very, very useful. Log base b of 1 is always 0. Log base b of b is itself always 1. So we have to keep in mind these four properties. So by using this property, now we can find out some value. Log base 19 of 19 is 1 because the base are same, so the value should be just 1. Log base 273 of 1. No matter what base you take, log function of 1 is always 0. Look at here, the property 1, 2, 3, 4. Okay, ln and e, they are inverse of each other, so the final answer would be negative 12 because inverse function, they would just cancel out. Log base 30 and 30, they are also inverse, so the final answer is just 10. 8 and log base 8, they are inverse of each other, that's why the final answer would be 5. So so this blue one is the graph of exponential function when b is greater than 1. So since we know that log base b of x is inverse of exponential function, and we also know that that graph of inverse function can be plotted by just flipping the x and y coordinate. For example, you can see here it's a 0 1, and on the log function it's a 1 0. So if you want to plot the graph of log function, you just have to switch x and y coordinate on the graph of exponential function. Okay, so so this is the graph of a log function with the base b, and because they are inverse of each other, their graph, you can see that they have mirror image with respect to this line y equal to x. We know that the exponential function has a domain, any real number, range positive real number, and then the exponential function, this b to the power x, has a horizontal asymptote y equal to 0. This one is the horizontal asymptote y equal to 0, and this exponential function passes through 0 1 point. Since log function is the reverse of this exponential function, so this domain becomes range of this log function. This range becomes a domain of this log function. This horizontal asymptote becomes vertical asymptote, and then y equal to 0 becomes x equal to 0, meaning this line x equal to 0 is the vertical asymptote for this graph of log base bx. And instead of passing through 0 1, it passes through 1 0, passes through 1 0. So the graph of a log base bx is just reverse, or just switching the x and y coordinate of the exponential function. So domain of log function is all positive real number. Range of exponential log function is all real number. As you can see, that domain is anything to the left, to the right of 0, and range is anything from top to bottom or bottom to top. Okay. Okay, so that's the relation you can see, because they are inverse of each other. These are the relation here. These are the relation. Now we want to plot the graph of log base 3x. So you see that this is it passes through 1 0, and then graph would be look like this. You can always find the points x and y. For example, x is let's say we know that domain of this function is any real number, positive real number. So you can take, any value starting from 0 to infinity. So at 1 it's a 0, at 2 it's a, at 3 it's a 1, and then keep going. But instead of doing that, you just have to switch x and y coordinate of the graph of 3 to the power x, because they are inverse of each other. So this is our graph for log base 3x. Okay, and then exponential function of this function, this equation is y equal to 3 to the power x, and since they are inverse of each other, the graph would be symmetric with respect to this line y equal to x. And then sometime you also have to use a transformation to find to plot the graph of log function. For example, here this one plus 1 means it's a, what is that, it's a horizontal shift 1 unit to the left, plus 2 means it's a vertical shift 2 unit to the up. So whenever we apply the horizontal shift, remember, we know that x equal to 0 is the vertical asymptote for this graph log base 2 of x. So whenever we do the horizontal shift of this graph 1 unit to the left, this vertical asymptote x equal to 0 shift to the x equal to -1. So as you can see that this is our vertical asymptote x equal to -1, x equal to -1, and then so the graph would be graph of this function log base 3 of 1 plus x look like this. But that's not the final graph, because we also have to add plus 2. That means we need to shift it 2 unit up, 2 unit up. So eventually our graph would be look like this, 2 unit up. Okay, so that's the graph for this function. So whenever we try to apply the transformation, whenever we try to plot the graph for log function, we need to apply the transformation. So in this problem we need to find out the domain of this log function. Whenever we try to find the domain, remember domain of the function log function can be found by making whatever comes after this log base a, whatever comes here inside this parenthesis. Let's say there is a box, then that in that box, whatever value you take, that should be positive. So that is how you find the domain. For example, in this problem, in that box you have x plus 3, so you have to solve this inequality, and whenever you solve this inequality, it gives you x is greater than -3. So domain of this function is, as you can see in this graph, anything greater than -3 is the domain of the function. So if you are planning to find the domain of log function, make this thing inside this parenthesis greater than 0 and solve for x. Okay,